So let me now just go through quite concretely how you go about building a Maxent model, and this is the kind of stuff that you'll be doing in the assignment for this week. So the first step is that we define features. So our features are Boolean functions, binary indicator functions over the data points. And what we're thinking about is what are things that we'll pick out sets of data points which say something distinctive about our classification task. So for something like text classification or sentiment, we're definitely going to want to include individual words as features, but sometimes those aren't the best or the only good features. For example, they're an infinite space of numbers like 3.42 or 7.86, and it's going to be hard to usefully use these numbers just as words, because most likely the numbers that turn up at test time weren't in your training data. So you can get a lot of value from defining more general features, which might be just simply word contains a digit, or it might be something more specific like is floating point number. But there are also many other cases of useful kinds of features. So in many languages, including English, the end of a word gives you information about its class. So if you have words like helping, making, drying, that you can tell that these words are participial forms of verbs by looking at that ing ending. Of course, this isn't always true. You'll get a word like sting, but nevertheless, it's a good indicator, and so a feature like this is something that you can be expecting to get a positive weight in a model if you're wanting to have a model that's classifying words for something like part of speech. So what we will do in class, and it's commonly done in practice, is that for each feature that picks out a data context, that we will just represent it as a string. So the string could just be the word, computer or whatever. But since we're also going to have other features like word contains number, commonly what we want to do is kind of have some informal namespace. So this might be the word equals computer, and this one might be the num equals decimal, or the feature here might be end equals ing. So we've got this informal namespace of features, and the reason that we want to do that is we want to represent each feature as a unique string, so we could use that in something like a hash map where we can then look up the weight for each feature. Now, of course, you don't have to encode the features as strings. You could encode them as some more general structured object, but in practice, a lot of the time, strings are used because they're just a fairly flexible and formal way to encode features. Okay, and then remember that this part gives us our phi feature, and then from the phi feature we're going to construct the f features, where the f features are going to be a phi feature and a particular class. So for a particular phi feature, we're then going to build a set of f features, one for each choice of class Cj. And then it's the particular f features, like f1, f2, f3, that are then going to be given weights like 0.3, minus 0.7, 1.2, or whatever. We concentrate on defining the phi features in terms of what are useful features for the problem domain, but you should remember that in the presentation that follows and in the code, that the code is working in terms of indices I of the individual f features, where each phi feature is then being turned into a set of f features, one for each class. How do you go about building a Maxent model? Well, normally to start off with, you define some features that you're just basically sure are going to be useful. So that might be things like words in the document, or the word before the word you want to classify, or something like that. But typically we go through an iterative development process where we initially build one model with some features. we test it on some development data, not our final test data, and we see how it does, and it gets some performance level, like it might be 57%, and we'd like to do a bit better. And so what we're then going to do is come up with a refined second model and then repeat it over, and we'll commonly do this a number of times until we've tried to come up with the best model that we think we can. And so the question then is, well, what do we do for this next model? And in general, you can look at the features and see which ones are useful as good features and bad features. Often the easiest way to make progress in practice is to try and define features that mark bad situations. So if you look through your classified development data, you'll see some piece of data and it's classified something as a drug, and it just shouldn't have been a drug. And so then maybe you can look at the actual observed data and see something about it. So maybe there's a smiley face here or something like that, and you can say, well, it just isn't likely that a piece of text which has a smiley face near it is going to be talking about a drug. And so you can define a feature for this combination. And so this kind of style of features where you target errors and find some way to explain to the model why that's a bad configuration is often one of the most effective ways to add features. Then for any particular set of features and their weights, what we're going to want to be able to do is calculate the data conditional likelihood, the probability of a class given the data item. Well, we already know how to do that. That's what we did in the preceding slides with the worked examples. But then secondly, we're also going to want to work out the derivative of the conditional likelihood with respect to each feature weight. So so we're going to want, a partial derivative of our overall probability according to a particular feature weight lambda I. This is what we're going to work through the math of in the next section, but crucially to do that, what we're going to end up doing is using those two feature expectations that I defined earlier. And so using those two things, we'll then be able to work out these optimum feature weights. Okay, so I hope that's given you a good sense of what features are in discriminative Maxent models, and at least some idea of how to go about defining them to build a classifier in a practical context. Though that question of what kinds of features are good is something that we'll come back to later when looking at particular problems after we've worked through more of the math and properties of maximum entropy models.